Hey, happy Sunday. This is PFG Live, the podcast dedicated to the writings of internet philosopher Hey Man, Why Didn't You? Who says, hey man, why didn't you just put the coolant out on the driveway and let it drain into the ditch? Welcome aboard. We got a bunch of guys in Discord. Welcome to DBX, Dale, Tucker, Paul, Andrew, Ted, and of course, John and Carl. Welcome aboard. And in YouTube, we got a bunch of guys checking in. Let's see. Tuck's Garage is reporting 34 degrees Fahrenheit with rain-snow mix in cold Buffalo, New York, fighting off sickness like it's a plague. I'm sorry. Dale in Canada says minus 16 degrees science and cloudy, up from overnight low of minus 32 science, which is minus 25 F for you guys following at home in Northwest Hoth. Meanwhile, and I'm not kidding, Paul Morley in Dallas, Texas reports 80 degrees Fahrenheit. I do not know how this works. And here in Windham, New Hampshire, temperature is currently 31 degrees Fahrenheit, 59% relative humidity. Winds are out of the northeast at 4 miles an hour. Let's see. Ted Hyde is with us from Casa Frog Pro Resources. At Kilo Lima Echo Echo reports winds are variable at 3 knots. You can't do that to me, DBX. Winds are variable at 3 knots. Visibility 10 miles. Broken at 4,600. And temperature 2.17. That's actually quite nice. Altimeter 3010 with the remarks, Merry Christmas, Happy New Year, stay COOLANT. That was actually well done. DBX, thank you very much, sir. Lovely sticker. Happy New Year to you. And let's see who else. Oh, look at who we have here. Indiana John is checking in with 32 degrees Frankenstein in Wentworth. Welcome, sir. Dave G. Is that the Dave G I'm about to talk about? 35 degrees, slight mist, 29.5 inches of the HG in Northwest Ohio. Is this D? Are you DG chip maker? The one and the same? Let me know. Is that you? All right. Well, welcome aboard, everyone. First of all, okay, good. Well, do I have permission to read your thing? I'm going to read your thing. I'm reading your thing. Happy holidays. I know it's busy, so I predicted a light crowd today because everybody's doing the holiday thing. So it's okay. It's cool. We're going to have some fun. And it has been a relaxing start of the holiday season. Thanks, Dave. I've been playing around in the shop and doing some 3D printing stuff. And one of the things I've been doing is designing some stampers. So there's this filament that I've had for a while and haven't touched called TPU for AMS. So it's a TPU filament, which is the squishy ones, except it is sufficiently not squishy so that it will work with the AMS unit on top of the bamboo. So I finally, with this little holiday break, decided to make some stampers. And I'm not going to dwell on it, but basically successfully made some stampers. This is one of the early prototypes of the what I call the platen or the stamper. And it's working out great. And Mr. Dale up in Canada started doing the same thing, and he made his out of FormLabs silicone, and it's even working better because that's it's squishier. So I'm pretty happy with that. That was a lot of fun, and I realized I was actually relaxing and having some fun in the shop. Paul is warning us that it's going to be 40 degrees any minute now. So there's a picture. No, I used the same nozzle diameter, Paul. I used 0.4 with TPU for AMS. They warn you, do not use 0.2. They tell you right up front. There's a picture of Dale's successful roll stamper. He made a roll stamper. I'm making a straight stamper. Let's see. Mr. C.S. Weltfab is reporting 72 degrees, cloudy, and very windy in East Tennessee. Welcome aboard, sir. Dare Machine, welcome. 38 Fahrenheit and foggy in Independence, Oregon. and you're here and you're above freezing. That's the important thing. So that was fun. It was nice getting through the orders. I got all the orders out. The last manufacturing I had to do, I think, for this year that brought us back to full inventory was 8-inch stones. And we had a nice order for 8-inch stones, and those went out and some in inventory. And you saw pictures of that on Instagram. By the way, if you're not following on Instagram, go to it's Spencer_Webb_NH on Instagram, and you should follow me there. Let's see. I got a really nice review from one of my customers who happens to be here today, Dave, and I would like to read it. And I do have his permission. He says, good morning. My first impression, awesome from the start. Now, he bought 6-inch PFG stones. As I opened the box, I could tell that a considerable amount of time and care went into just the packaging. So I wasn't surprised at all with the quality of the stones. I gave them a quick test on a slide and a gib. Was impressed with the smoothness of them as I worked the angles and bottom of my parts, the machine parts. Stones did a quick job of showing me the pattern I expected to see in them and did an efficient handling of taking down and smoothing out a couple of nicks in the parts. Excellent. Within the next couple of weeks, I will start assembling the components and might even do a short video showing the process of it and use of the PFG stones. Thanks again, Dave G., also known as DG Chipmaker. Go follow him on the various socials. Dave, that was very, very nice. Thank you so much. I appreciate you. What else? What else is going on? So I was at the shop and I was talking with. No, this was earlier this week. I was sitting in a parking lot. And I get this phone call from my good friend John Saunders. And he says, well, he prefaces this with a text message, and he says, "Can I run something past you?" I'm like, "Yeah." So he calls up, and the topic was basically dealing with coolant, and I'm not going to give you any spoilers until we get into this. And the idea was, well, we're going to talk about it in some detail. And then I shot back to John some of my experience with coolant and dealing with not only buying it, using it, and getting rid of it, which was the big one. And we'll talk about that today. So we said, hey, could you guys join me and Carl on a call? So the three of us got together. Carl is a chemist, and he's a very, very good chemist. And you've heard him on the PFG.Live before, usually correcting me, which is appreciated. And the three of us got on a call and we talked, and I'm like halfway through this thing, I'm like, we have to do this on the live because there's so many people that would benefit from this information. So here we are. So I would like to welcome aboard. Where is he? There he is. Well, one click away. There he is, John Saunders from Ohio. Welcome aboard, sir.
Good to see you, sir.
How's Zanesville today?
Life is great. Zanesville's not so great. It's kind of that 40-degree and rainy, the temperature that in situation that nobody's happy about.
Well, we're about to get some of that sort of rain, maybe. Like, oh, it's going to be 33. No, 31. No, actually, it might be 32. No, it's probably going to be 28. And I don't know what's going to happen. So we'll see what happens. And also with us today is Mr. Carl Tauber. Carl, how are you?
Good, gentlemen. Good to see you.
You're making some assumptions. So I'm going to ask, so you guys know John Saunders, but I will tell you that he is the proprietor of Saunders Machine Works. He has a great YouTube channel, wonderful business, makes some wonderful parts. The puck chuck, the vise. What's the name of the vise?
Mod vise.
The mod vise, exactly. I was testing you, and has a great. We've known each other for years, and you use coolant throughout the shop, and it is a never-ending source of amusement. Is it not? Carl, you want to give yourself a quick intro and tell everybody your background, because you're going to be using some big words today.
Well, hopefully I'll prune out the big words, but basically, I was trained as a chemist and have actually done some formulation of things like emulsions and so forth back in the Stone Age. And I've done analytical work and physical chemistry and so forth, mostly relating to making measurements. So what I don't have is a machining background. I'm not a machinist. What little I know is from watching the rock stars like Adam Booth and the other suspects. So if I put my foot in my mouth, please correct me. I need the education.
I think there's a lot of feet to go around, so don't worry. But I was able to tell Carl from our conversation that this was right up your alley, because coolant is an emulsion. So let's start with the coolant. Could you explain in words that any of us will understand what is an emulsion and why is coolant an emulsion?
Well, let me step back a little bit and talk about water, which is the thing you want to use for coolant because it has an enormous heat capacity, like orders of magnitude higher than anything else. And it's low viscosity, so it's easy to excite turbulent flow, which is more effective for heat transfer than laminar flow. The problems are that water is a lousy lubricant, and it is also potentially corrosive. So you want to protect your machine tools and your parts from the corrosive effects of having water present, and you also want to have some lubrication, which water does not provide. Now, an emulsion is essentially a mixture of two liquids that are not miscible. And in order to do that, you basically take a molecule that has a part that looks like water and a part that looks like oil, and with suitable fiddling, you can get water to essentially absorb the oil into an emulsion. Now, an emulsion?
I'm sorry.
Go ahead.
I was going to ask you if there's a real world example of an emulsion that we're familiar with.
Mayonnaise, milk, hollandaise sauce. Those are the common ones.
Okay, cool.
And basically what you start out with is small particles that can absorb oil, because in this case you want water to be the continuous phase and the oil to be the dispersed phase. Okay. John, you're holding your hands up.
So John's been counting.
What I'm happier about is that Spencer knew exactly what I'm doing, which is I'm counting the number of not little boy words.
Yeah. So let's do a little bit of let's just stop for a second and do a little vocabulary. I'll say the word, Carl, and you give us the definition. Miscible.
Okay. Can be mixed together.
Excellent.
I thought miscible was
not that kind of miscible. No. We want to listen. We don't want to be taken off the air here. Okay. We'll get to that. We'll get to that later. Which, by the way, we'll point out is in your living room. I'm not saying. Okay.
Can't be too safe these days.
You can't. That is absolutely true. So, miscible. So some of the other ones were laminar flow versus turbulent flow.
I think you engineers are going to be better at explaining that than I am. my understanding of laminar flow is that it essentially provides an insulating layer close to the surface of whatever it is it's flowing against, which impedes heat transfer.
I think for our purposes, laminar flow means a flow along a surface that remains in the direction of the surface and doesn't have any component normal to the surface, at right angles to the surface. Whereas turbulent flow will have some component normal to the surface and some component along the surface. So the reason that's important in flying, like in aviation, if you want your wings to work, you better know the difference. But for our purposes, it's the water needs to pick up some heat and get away from the surface, and it does that best when it's turbulent. Am I reading that right?
That's my understanding. Yes.
Okay. Let's see. What was the other ones? Did I miss any, John? Well, we'll get back to them.
I think probably the point that John was raising was the emulsion has a part that is called the continuous phase, and that is essentially what you think you're interacting with. And the disperse phase is the little droplets that are inside that are carried in the continuous phase. Now, that can look clear or it can look milky, depending upon the particle size of the droplets. Large droplets scatter light more effectively, so that that's why milk is milky, and skim milk is less milky because it's got less stuff in it. So in this case, you want water to be the continuous phase, and you want the oil to be the disperse phase. Although with proper formulation, you can get it to be the other way around. Although I don't think that's of interest here.
So, in the old days, when I first started learning about coolant, there was all of this woo-woo. And John, jump in if you have something to say about this. There was all this woo-woo about adding the oil to the water, right? Adding the coolant to water and never adding the water to the coolant, or it'll never mix properly.
That is, I'm told, very much brand or even coolant model number specific. And by the way, as a preface to this whole conversation, both today and what you and I have been talking about offline, I'm trying to just find facts, because I do find there's a lot of old wives' tales in the machine shop world of, oh, you can't do this or you can't do that. It's probably worth throwing out quickly that with rare exception, perhaps, there's really three types of coolant that we would incur in the modern machine shop. One would be a true oil only coolant. So we run pure oil in our Williman. It's a bit unusual, I guess. It's common in Swiss machines, et cetera, but generally speaking, you don't find true pure oil coolants. But there's funny stories of guys that will run vegetable oil or a type of vegetable oil as a coolant, where if the coolant's clean, it's edible. The far extreme is a pure synthetic. I think the most popular one I've heard of, although personally I find some bad stories around it, is the Blaser product, the Synergy. But it's a pure synthetic, so just nothing about it is natural. It's all lab and no dinosaur. And then what most of us seem to use is a semi-synthetic. So it's got some quote unquote natural, dino oil, and it's got some lab oil, and it's a concentrate that you buy, and then you mix with quote unquote water. Although I suppose that's probably worth talking about today, because what I have as water and what you have as water is not truly H2O. It's obviously got minerals and other things in it from city or as well, or with city water or well water, et cetera.
So,
yeah,
go ahead.
A
Carl.
comment there, John. Natural is often confused as meaning good or beneficial. And the short answer to that is there are natural products that are just horrendous. And there are plenty of synthetic products that are quite harmless. So the idea of being natural versus synthetic doesn't tell you anything.
Sure. I didn't mean to imply that. I mean, I think from a car guy standpoint, like synthetic oil's better. I'm not going to get into edge cases of engines and so forth, but like, whatever.
I want to talk. I want to finish defining terms, and then I want to get into our personal histories with coolants.
Okay.
So I think we've established that you got water, you got coolant, which has got a strong oil, typically has a strong oil component. You mix them together, and then inside this mixture, there's a thing that keeps them together, and that's the emulsifier.
It can be called a surfactant. It can be called a soap. It can be called an emulsifier. It's whatever is the magic that holds it together, basically.
Okay. So in a perfect world, we mix all those things together, and we have this lovely, clean, milky, wonderful stuff that we pump through our machines, and it's our coolant that we like. But I think we all end up with this history of fighting with it until we get something stable. So my personal, well, before I do that, are there any other terms or background knowledge that we have to nail down before we can go further down the road?
We're going to use the word crack, which it just means, as a layman, it just means Control Z on the emulsifiers.
Yeah. So what would you call it?
I'm sorry,
Carl? What do you call cracking in the real chemical world?
I'm not sure that there's a formal term. I would call breaking the emulsion.
Okay.
And that is going to depend on against essentially who the players are, and certain emulsions can be broken more easily than others. And the manufacturer can tell you how to do that. I think, John, you mentioned before we started that you had spoken to a chemist who basically told you how to separate one of her emulsions, and
we'll get. I don't want to take that exit yet.
Okay.
We'll put a bookmark on that because we're getting there. John brought up at a very interesting point, which is, what he has for water and what I have for water and what Carl has for water. They're all different waters. And one of my hot buttons when I started using coolant is the coolant manufacturer telling you, oh, you should use tap water to mix this. Like, sorry? Like the words tap water is defined somewhere? Like you know what's in my quote, tap water? And
I think what they're saying there, Spencer, is that whatever their product is, it is not sensitive to the kind of stuff that is in the water that comes out of your tap. And that obviously varies with location.
I wish that was the case. I wish that was the case, Carl. But in fact, it was, you should use it because it needs some of the fill in the blank that tap water has in order to make it wonderful. And I'm like,
if that's true, the formulator should be taken out and shot, because they should be putting the stuff in that is required to make it work.
And that's what I did.
In other words,
I don't mean I shot them. No, hang on. I didn't shoot anybody. But yes, I agree with you. That's what I flagged on. Go ahead, John.
We had done a video years ago talking about some coolant basics as a small machine shop, and I perpetuated what is something I've now been corrected on recently, and I'm going to trust that my more recent information is more factually correct. You do not need to start with tap water or it's interesting, Spencer. You really raise a good point. It's like, are you permitting, are you encouraging, are you permitting the use of certain things? Are you denying the immediate use or the perpetual use of something? But I had been taught and did and believed, because it sort of passed the sniff test, that it's good to start with quote unquote tap water. For us, that's a city water that has some hardness in it, because those hardness minerals can help act or react with the surfactants or emulsifiers. But basically, to give a really simple analogy, and Carl, don't shoot me if I say this wrong, true pure hydrogen dioxide isn't even conductive. It will not conduct electricity. It's so pure, but it's also really bad in the sense that it's going to grab anything it can find. For example, again, I'm going to keep this in layman's terms. If you run that pure water through a Haas machine tool, it's going to find exposed cast iron and exposed zinc and exposed brass in the form of fittings and components, and it's going to start leaching them or grabbing them, and it's going to react or rust, or all sorts of bad things will happen. So water, and you never see true pure water in nature, I'll say that. And so starting with hard water or tap water in your bill is either good or fine. That's since been corrected. But you don't want to keep using it over the life of 1 or 2, 3 years of a sump, coolant in a sump, because the water evaporates, those minerals don't. So if you keep using tap water that has a certain hardness, you're going to increase the hardness in that concentrate in your tank over time. So it's a whole fill up with tap water, top off with DI. I have since been told that you might be okay doing that, but you do not need to do that. And if you can start with something like DI water or RO water or whatever you want to use that's true, good, pure water, and only ever use it, you are totally fine to do so.
And that is what I landed on, the same philosophy, unfortunately, by trial and error. Mr. Tim Beatty in the chat says DI water. I don't disagree. Machined Creations says, I use distilled water in my Tormac. It's still great after 3 years. So when I finally landed on, I'm using distilled water and a high quality coolant, which is where I'm at now, I have used the same batch of coolant for over a decade now. Now, I'm not running a production line like you, but it's been 10 years and it's not gone bad. It's not etched away any of my machine, and it's distilled water. So I think
you're doing distilled, Spencer?
I am doing pure distilled water. Affirmative.
So you buy that from the grocery?
Nope. Well, the first fill of my machine I bought from the grocery. I make it. I have a still downstairs.
Okay. I want to say, I think that's something that I got confused, because you hear the word RODI a lot. Right. That's not distilled. That's reverse osmosis deionized. So the DI there is not distilled. Distilled is like boiling off like how you make alcohol or something.
Yeah, well, I agree. But what I'm saying is I use distilled water. I used it from the beginning. I continue to use it. So that's as close to dihydrogen oxide, as you called it. It's scary when you say that.
Did I say it wrong?
No, you said it right.
Okay.
No, you might have said hydrogen dioxide, which, by the way, will explode the planet. But that's not the point. So early in my...
Can't be too safe.
No, listen, I respect you, okay? I know the range of that thing. I started with my water, right? They said, use your tap water. And I think it was, I don't want to throw anybody under the bus, it was a Trim brand coolant, which has nothing to do with my story. I mixed it with my water, and I had problems. I was getting corrosion. I was getting all sorts of, like, you know the spider corrosion you get on metal sometimes, and it showed up on part of my machine, and I was like, okay, now I'm pissed. So I get on the horn with, eventually, this took a while for light to dawn on Marblehead here, but eventually I went looking for a water chemist, and I wanted to know what the heck's going on here. And I found one. Short story is, I found one, and he said, send me water samples, send me whatever paperwork you have. So I did. He looked at he analyzed my water, looked at my water samples. I get on the phone with him one day, and this guy loved water. This was his life. And he's looking at my numbers. He's going,
and any good chemist loves water. It's magic.
Right. I know. We'll talk about why in a minute. I want you to talk about water. So, but let me finish this part of the story. So he looks at, we're on the phone talking to 45 minutes. He's asking me questions. We're going to things. All of a sudden, you could tell the light bulb went on in this guy's head. And he says, wait a minute. He says, I think I got it. I said, okay. He says, you see down under chlorides where it says whatever it was, 134 parts per million. I go, yeah. I said, but that's under the limit. He says, yes. But you see up there where it says pH, and my pH was slightly, I don't remember which direction it was. I go, yeah, that's my well water. He says, and I said, that's within range. He says, yes, but the combination of those two things is causing your corrosion problems. And that was it. That was like my brain exploded. You couldn't have figured that out unless you knew Carl. And you called Carl.
I'm not sure that I could do the same thing that your chemist did. But what I would have said, I think de novo, is that you're probably better off using either distilled or deionized or RO water. They're basically flavors of pure water. The techniques of making them are different, but the end result has, for the purposes here, is very similar. And basically what it says is that there's no extraneous stuff in your water that you have to worry about. And just like people who make detergents for washing clothes have stuff that they put in there so that you can wash your clothes in hard water, as opposed to making all sorts of nasty precipitates, that basically contaminate your clothes. It depends again on the formulator. So
here's my philosophy. This is what I want all purveyors. Oh, precipitates. Sorry. Precipitates means, Carl, tell me if I'm right, the stuff that falls out of solution. Like it looks
solid stuff
that
comes out of solution. Correct.
Okay. It precipitated out. So when I'm emperor, this is how coolant's going to work. Okay. You provide me the coolant concentrate. I'm going to mix it with distilled water. Okay. John's going to buy the coolant concentrate. He's going to mix it with distilled water. At the end of the day, I have this magnificent coolant. John has this magnificent coolant. We both run it in our machines, and there is absolutely no difference. Here's how the industry works now. I buy my coolant concentrate. I mix it with my well water. Okay. John buys the coolant concentrate. He mixes it with his city water that has, chlorine and other things in it.
Fluoride, who knows? Yeah.
Okay. He gets one result. I get another result. That is no way to run a business. Okay. End of rant. So yeah, I hate that. And I have
that's why I would recommend using purified water to eliminate that as a variable, essentially.
Amen. Let's define a few things, because I know that a couple of guys who are in the chat use reverse osmosis deionized water. I believe, John, that's what you're using, right? Your RO water?
RO, I don't necessarily use the DI, don't do a DI on it. Sometimes I do, but yes, it's reverse osmosis.
And I use distilled water, which is literally heat distilled. And I have a little factory in my basement. So we have a big storage of distilled water. Carl, what's the difference between distilled water? Well, let's start with tap water. Tap water, reverse osmosis water, reverse osmosis deionized water, and distilled water.
Well, the distilled water, I think people understand, it's basically boiled and condensed. And that can yield highly pure water, but the still design is critical because when you're boiling, you can have droplets that get carried over through the condenser, and a good still design is essentially engineered to prevent that happening.
Just a point of information. My still is a home 1 gallon still I buy them off of Amazon, and I've been buying them, wearing them out, and buying new ones for years. So it's just your basic consumer still.
Probably perfectly adequate, certainly from your results. If when it comes time to replace your still, you can also buy simple RO systems on Amazon, and really it's a matter of cost and also water pressure, because for RO you need fairly substantial. If you have city water, the incoming pressure is higher, because reverse osmosis basically means the water has been pumped through a membrane, and the membrane allows the water to get through, but it does not allow salts and other materials to get through. So it's basically a fancy filter. And there's always going to be some leakage of ionic material, salts. And that's what John was talking about in terms of deionizers. You use a deionizer that is designed to essentially absorb any ionic materials that are in the water. And my guess is, for your needs, that is not necessary. And that sounds like what John said, is he doesn't deionize all the time. So
can I jump in?
Sure, please.
So the most common water treatment that I've seen at larger facilities, which Saunders isn't, but we're getting closer to being at that point, is a commercially surfaced DI only system. So this is where you have usually 2 or more tanks, and they are, I believe, I'm going to keep it, again, simple terms, beads in there that perform the deionization action. This doesn't need it doesn't need incoming high pressure like an RO membrane has. It doesn't involve the electricity or other hassles of a vapor or a distillation process. It just exchanges water through these DI tanks, which is actually quite great. The one major downside is if you don't maintain it. In other words, if you let a tank get, I'm going to use the word saturated, but if a tank is done doing what it can do and needs to be swapped out, and you don't swap it out, it will start putting salt water into your system. And it's also something where for most shops, you're going to be looking at well into the hundreds of dollars a month for that sort of a service. So for many of us listening with small shops, you're better off with the aquarium RO system.
Yeah, it's you basically have to sit down with a pencil and ask yourself what's going to be the most cost-effective approach, and obviously that is going to vary with the consumption, and also with the quality of the feed water. If you have particularly hard feed water, the deionizing systems are going to, as you say, are going to have to be frequently changed. If you have relatively soft water, then you'll get very, very much better life expectancy. And if you're contacting a supplier of that service, they should be able to tell you, roughly how many gallons you can produce. And in general, what they will have is what's called a conductivity meter, where they measure the conductance of the water, and the water is conductive because it has ions in it. And when you get breakthrough, essentially, the conductivity meter will tell you that it's time to change the deionizer.
And you could have a conductivity meter for $30. I mean, they're off the shelf items.
Oh yeah, they're cheap.
So,
but that's why I like RO, because if I don't change my RO filter, the worst thing that happens is I just get basically tap water, or I get more wastewater coming out, which stinks, but whatever. But there's no catastrophic outcome like there would be where
My
your RO
my
treatment
guess is
systems.
my guess is, John, that as the RO filter gets loaded, you'll lose flow rate.
Right.
But it's not clear to me that you will get breakthrough of anything that you don't want. I don't know that, though.
So I just want to recap. Okay. So tap water has stuff in it, and it could be chemicals that your town puts in. It could be schmutzel from, the pipes and stuff. It could be minerals. Well water has lots of minerals in it. So that's that's so-called tap water. And then we go through different systems. Distillation, perfect distillation, will result in H2O with nothing else coming out one end, and you're left with the minerals and whatever in the pot after all the water's out. I'm going to put an
In general, no still can make water that is as low conductivity as a deionizer. But my guess is that you're talking about something here that is academic. In other words, there's guys like, the people doing semiconductor manufacturing that go Looney Tunes over the purity of their water.
Yeah.
And I used to be in that business for a period of time, not semiconductors, but, measuring high purity water. And the point is that I don't think the needs of a machine shop are anywhere near that severe.
Yeah, I want to stay away from one of the guys in our chat, Mr. Tim Beatty, is also in the semiconductor industry, and he says RODI is the starting point. So they go from there and they make it better. So again, we have distilled water. RO uses a membrane technology to give you good water on one side and the stuff that you don't want in it on the other side, keeping it simple. A deionizer is going to take out the ions that are left over, and I want to define that real quick. And using either one of these branches of the system, you end up with water that's basically got not much else in it. And let's just talk about ions for a second, because people hear about deionization and ionic filters and all this kind of stuff. I'll let you give us a simple explanation of ions and a simple example, Carl.
Well, the simplest example is salt, sodium chloride, which in its solid form is composed of positively charged sodium ions and negatively charged chloride ions that are held together quite tightly by electrostatic forces. And one of the things that is magical about water is that water can supply the energy to separate the sodium and the chloride, and you still have a sodium ion and a chloride ion, but they are now each surrounded by water molecules that keeps them happy. And those are examples of ions. The other things that you're likely to see in water are calcium salts, magnesium salts, and possibly iron, and hopefully not lead. And that ties back to what John was talking about, the high purity water that was put into the lead pipes in the place in Michigan, basically mobilized, it was corrosive to the lead and, put lead into the drinking water. Whereas, the less pure water was less corrosive to the lead. But that is not something I would call a generalization. That was a fairly specific issue.
So ions are things that have a charge. Sodium chloride in salt breaks down to sodium and chloride inside of water, and one is positive charged, one is negative charged, And if you try to run
Correct.
if you try to run an electric current through that solution of salt water, you will get conductivity.
Correct.
Okay.
Is that how you make an ion engine?
We're not clear to discuss that right now. And by the way, the ion engine, we just finished developing the ion engine that will fit in that thing right there behind you. I'm just, but I don't want to another podcast. So, Mr. Tim Beatty says Valence Band needs to be mentioned. Tim, that's a rabbit hole I do not want to go down. John does not have enough fingers to talk
if
about.
If someone says covalent bonds, I'm hanging up.
You're at least they're not magnetic. Oh, sorry. There's Unix carbide. I apologize. Okay. So we got water. I think we've arrived at water, and I think also I've gotten a chance to wave my fist in the air and say we're going to start with good water. And you guys that say you need tap water to make your coolant work, you could see yourselves out. Okay, we're going to start with good water. See ya. Yes, you in the back.
I want to make it clear to the audience that none of this has anything to do with why I called Spencer.
We haven't even gotten there yet. Okay, we just got to water. Okay, fine. I want to spend a few minutes on choosing the coolant. Not a lot of time because that's a religious discussion, and I don't want to go there. But you mentioned there's a couple of different types of coolant. You've got pure oil. You've got
there are only use semi-synthetic. If you know enough to go pure oil or pure synthetic, more power to you. But if you're listening to this and you don't know, go semi-synthetic.
Okay, we're going to talk about semi-synthetics. So semi-synthetics include the stuff that we use, which is the Qualichem, right? It's
250C and 251C.
Yeah, and I use 250C. I brought my data sheet up from the shop. This hangs on my wall, just so you know. Wave the flag. And I would say, I'm going to just throw this out there: 90% of the coolants in use, from home shops to medium-sized businesses, are going to be semi-synthetics. Would you agree with that?
Again, I think what happened maybe 4 or 5 years ago was somebody in our industry got on their soapbox about, or their media box about Synergy 735, which is a pure full synthetic, and many people had disastrous results, which are beyond the scope of this call. Blaser ended up quietly releasing a second rev of it, and I don't care. I don't have an opinion other than to say, I don't have a vested opinion other than to say the juice wasn't worth the squeeze. Pain in the butt. I hated it. It messed up our machines, messed up any other people's machines. Stick with a semi-synthetic. We use Qualichem. We're quite happy. Many are. I'm not here to tell you whose brand to use, but a semi-synthetic is just, life is better.
Can I just say something in favor of Blaser? Will you hang up? Don't hang up. Don't hang up.
No.
I never bought a shot glass full of Blaser coolant. But the one thing they did that I applauded, I stood up and applauded, was they said, here's our new fancy coolant. You must use distilled water.
Sure.
Right? And I thought that in the world of coolant, that was huge. It was like, wow, somebody actually said, we're going to control the process. You use distilled water, you used our coolant, give us all of your money, and come visit Switzerland. So, okay, that's the one thing that I applaud them for. And nobody wants to hear that because it costs money to get a one of those cubes of distilled water, or making your own. Moving on. So we're going to talk about the most common coolant. So John and I both happen to land on Qualichem, hashtag not sponsored. They seem to be really good folks. One thing I went through in my coolant history is I went to Hankstofers. Hankstofers is another good company. And I was all like, gee, they have a green coolant that's made from corn oil. And I thought I was going to do the green thing. And that coolant had a failure mode of oxidizing and leaving a brown sludge on all the machines. And it was like horrible. And eventually I called the company and they said, yeah, you have to clean it off with isopropyl alcohol. Not, oh, we've never heard of this, but you should try isopropyl. It was like, oh yeah, you have to clean it off with it. I'm like, we're done. So I had an intern clean all the machines with isopropyl alcohol, and we flushed that stuff out. And that's when we switched to Qualichem. And I've been using Qualichem for over a dozen years, and I've been very happy with it. So this is not a coolant commercial, and this is not this is why this coolant's better than that coolant. But I will say one thing: once you use full flood coolant, it's like a religious experience. You'll never go back. It's fantastic. Tool life, chip control, everything gets better. You start growing hair in the right places. You look better. People start noticing you.
Wait till you go to a true full oil. Tool life is even better. Service finishes are even better, but it's a pain in the butt.
Mr. Tim Beatty says, I'm getting a single CNC machine with through spindle coolant. I just want something that doesn't ruin it. Spindles are expensive. We don't have any particular opinions, but we have some opinions. Mr. Unix Carbides from the Brooklyn, New York says, can I point out something here? As a machinist adjacent software person, you are all kind of on the verge of nailing down an open source universal coolant formula, Libre coolant, so to speak. Okay, that was for the software guys.
There is kind of a funny joke about the commercial side of the business of selling concentrate, and it's an obvious point, but the reason companies don't just ship you coolant and they ship you concentrate is because it's expensive to ship water. So they send you a concentrate, but then the second tier thinking behind that is if you're going to shop and compare coolants, you need to understand the how much concentrate you need to achieve the bricks you need, because it can actually vary by a significant amount. In other words, we buy ours in 55-gallon drums. Smaller shops may buy a 5-gallon pail. Bigger shops buy totes, or actually, Qualichem actually has a tanker truck for some shops, which is crazy. But if I'm buying this, let's go with 55-gallon drums, costs us like $1,700. How many gallons at 8% or 10% bricks does that make? Because the more concentrated the concentrate is, that means the less of it you have to buy, and the longer it goes in the different, at least compare apples to apples.
Right. Yeah. I run 7.5% dilution in my machines, saws, and even the lathe. I'm sorry, the other machine. Almost said it. Sorry, John. Oops. He terminated. Well, thank you. I guess that's the end of our...
Is it safe now to come back?
Yeah, hang on. Let me check. Yeah, close that. Yeah, don't show it. No, I don't care if it has a sticker on it. Just close. Okay. Yeah, it's safe now, John. You're okay. All right. So 7.5%, except in the grinder, 3.5%, but the same stuff, the exact same stuff. And I'm very pleased with that. So you're running 8 to something percent, and that's all good. And that's an emulsion. We now know what an emulsion is, and we now know what our water is. So here we are. We machine away. We go for months. We make parts, thousands of parts, perhaps millions of parts. We ship them. Shipping is easy. We ship them all over the place, and comes the time that we want to change out our coolant. And what do? Well, we get one of these big totes and we pump all the old coolant into a big tote. And now we have to deal with it. And this is what nobody wants to deal with. So we'll give perspectives from a small shop, big shop, and chemical point of view of what's going on here. But if your coolant is used up, whatever that means, it could be full of contaminants, who knows, and you want to get rid of it, Houston, we have a problem. You have this emulsion, you have this mayonnaise, and you want to get rid of it. Let's start with the easy route. You own you're big fancy guy with a big fancy machine shop, and you want to get rid of it. What's the simple way to do it, John?
Actually, the only way I know to do it is through a safety clean, I'm sure they have competitors. I'm not actually aware of any. We called them. They had to take a sample, and we had to go through a certification process with them. I don't actually remember if that cost money. I don't think it did. We have to use them once a year, or we lose our certification, which makes me think maybe it does cost money. And they come with a vac truck, so it's just a giant vacuum, like a vacuum truck. It looks like a tanker truck, but it has a suction nozzle on it, and they just suck it away. It's quite easy in many respects because they just show up. They literally take the problem away from you. They send you a bill. Where it's not easy is it's actually been hard for us on a maybe an unrelated note to schedule them. It's just always been a hassle, and they have some pretty heavy fees in terms of not just the price per gallon, but also the pickup side of things, like multi-$100 invoice bills just to show up. And it's a lot of hassle. Like, you got to store this coolant, to wait for them to come, and then you want to make sure, the last thing you want to do is have them come. For us, it's about once a year, and then 2 weeks later realize you have a tank that you need to swap out.
So basically, once they decide you're not evil, you write the check, it disappears, and you're done.
Exactly. And it's done, obviously. I think I can barely read the comments, but to say the obvious, what I'm trying to make sure, and this is one of the reasons I called Spencer, is I'd like to make sure we live in a world where people are not encouraged to do the wrong thing. And the more expensive and the more hassle something is, the more likely somebody's going to say, well, it's only a gallon, I'll just pour it in the backyard or pour it down the drain, et cetera, et cetera. So it's kind of like, well, yeah, let's make it easier for people to understand how to make better decisions to handle this stuff the right way.
So as a small shop, I got to that point with a bunch of coolant. In fact, I did change coolant, so I had to pump out the old stuff. And I went down this path, and I'm like, what do I do with this coolant? And the first thought was that, well, it was impractical for me to call Safety Clean and say, come get my coolant. And I don't remember, it's been a lot of years now, but looking into that, it was going to cost me not less than a couple of $1,000. And at the time, that was not going to happen. So I did some research, and I thought about cracking the coolant. Now, well, let's back up, because when we had our conversation, you had an idea that I thought was pretty cool. And that was, and I'm paraphrasing you can clarify here. You said, hey, if Safety Clean is going to come and pick up 500 gallons of coolant, why don't they just come and pick up 500 gallons of coolant less some of the water, right? Let's get the water out of it, and then we're going to end up paying less for them to haul off the water. It's the same problem as talking about shipping water is
Sure.
Taking away water. Am I capturing that correctly?
The simple question to keep it away from some of the complexities of dirty coolant that has whey oil mixed in, been cut metal for years. Let's just say you mix up a brand new batch of 251C, and that night you realize, oh my God, we have to move our shops. I have to empty this tank. Brand new coolant, never touch anything. If I just added, I'll make up these numbers, 5 gallons of concentrate and 95 gallons of water, I don't really want to pay to have 100 gallons of mixed coolant removed. Why can't I get back closer to 5 gallons of concentrate? And of course, it wouldn't be perfect, but I think everybody gets the idea. My idea came from the fact that we all know that in shops you lose coolant through evaporation and runoff on your chips and so forth. And at an industrial level, I'm quite certain, although I can't speak to the actual federal or state laws, but you can't run your business around intentionally allowing evaporation as a means of disposing of stuff. So you can't just evaporate it for fun at scale, et cetera. Again, not an attorney, but you can't. But my thought was, wait here, can't I somehow take this brand new, perfectly fresh batch of coolant and I started thinking through a system where you could have you don't need it to happen quickly. You could have it aerosolized against a angled plate. I was thinking of like a coal blast furnace where if you make it thin particles, it evaporates more quickly. And you could have a hot plate that's heated by the sun that helps warm it up, which evaporates quicker. A fan blowing across it, which is that convection, helps it evaporate quicker. And then you'd have a plate over the top so that rain doesn't mess this up, and also it doesn't evaporate into the air. And you could try to separate these two things out. And the really, really short answer is that could work, but it's not practical from an operational standpoint. And the real ringer, which is a point that Carl helped drive home, is that you would still need to have that water tested because it's unlikely that water can be flushed down the drain. And so you're left with the same situation where you're paying Safety Clean to haul away 100 gallons. You just already separated it for them.
So I would, go ahead, Carl.
If you separate or break an emulsion, it is likely that there's going to be some of each component in the other component. So your ability to get pure water is unlikely. Let's put it that way. And you would have to pay somebody to tell you that you have pure water and that it is safe to dispose of. And that's probably more expensive than having all of it taken away. Although I haven't quoted that, so I'm speculating.
On the flip side, Carl, from a very practical standpoint, I don't think anybody is going to throw shade at any machine shop owner who took a part out of the machine and then walks over to the sink and washes his hands, knowing that, yes, there's some Qualichem or Hanksters or Trimsol on his hands.
Right.
Yeah. Plus we're living, we're working in the shop. I could tell you that when I'm grinding stones and I do a session of grinding stone, I have to add water to my coolant tank because the water evaporated. And I am unconcerned about the water vapor that left that tank. I have zero concerns about it. And I'm sure. So from a practical, there's legal, environmental, and practical. They're kind of different requirements. From a practical point of view, I think if you did your evaporator type thing, I don't think it's a bad idea to reduce the volume. From a legal point of view, if you ask the question, you have to write a check. So nobody wants to ask the question. From a small shop guy like me, when I had to crack a coolant, I siphoned off. I successfully cracked the coolant. Stay tuned for that information. I successfully cracked the coolant. I siphoned off the oil very thoroughly, and then I brought it to oil recycling, and it was recycled. Awesome. And then the rest of it was evaporated off, and it actually went, from a practical standpoint, it went really well. Cracking it was a great idea, and we're going to learn a little bit more about cracking. Cracking coolant, just saying. I want to clarify that. But Carl makes a good point, which is that it's not a perfect solution. It doesn't crack it.
Well, it sounds like it's a good solution for a small shop doing it once, but as you scale up in volume, it seems to me that becomes impractical.
I may add the context that led to this phone call. Frankly, I think it always helps to put numbers to this. Was that I vaguely recall we spent something like $2 to $3 or $3 to $4 a gallon for Safety Clean, plus the pickup fees and other fees. It's like the Ticketmaster convenience fees in there somewhere as well. We would every year it would be like $700-800 or something like that. Maybe it was a little less. The last one we had was almost $2,000, somewhere between $1,500 and $2,000, and the fee had gone up, the rate per gallon, but also we had some more coolant. So it's just also some of us having grown. But that's part of what led me to think, is there a better way? Because as a small entrepreneur and a shop owner, man, that's money I hate to literally pour down the drain. But for $2,000 to have somebody literally and figuratively drive this problem away from you in an ethical, legal, safe, environmentally friendly way is totally the right answer. But there are a couple more things I would love to throw out here in a minute or two that I learned that might actually be helpful for folks. But I'll let Spencer get back to his wonderful MC.
So, well, we keep talking about cracking the coolant, and I asked Carl about, what that means and how to go about it. Is there a simple specification for a tool that will crack an emulsion, Carl?
Not one that's universal. In other words, each type of emulsion is going to have things that will break it and things that will not break it. And I certainly am not competent to make an a priori prediction about anything that'll work universally.
So we're not putting you on the spot. But if we handed you a cup of mayonnaise and we asked you to crack it, what would you do?
Give it back to you and tell you to, piss up a rope.
Thank you very much. And that's the PFG Live for today. You're absolutely correct.
May I share what I learned from QualiChem?
First, let's talk about what we learned from the internet. Because let me tell you, folks, if you're thinking about this and you go to the internet, be careful. But one of the things I saw was salt, right? And one guy was talking about softener salt. And I tried it, and it kind of worked, but it needed so much softener salt. And softener salt is the stuff you buy at Home Depot for your water softener. It's salt. It was not really practical, so I kind of abandoned that. I then learned about specific chemicals for cracking coolant. I'm wondering if I should talk about that before or after you talk about your thing.
Go for it.
All right, let me just... So what I discovered was that there was a chemical designed to crack emulsions, and it was a chemical that was used to help clean up oil spills in the ocean. Now, you can imagine if you dump a bunch of oil in the ocean and it gets all mixed up by the tide and the surf and the wind and the stuff, you have probably a pretty messy situation, some of which is going to be an emulsion. So this company made a chemical. Now, I haven't talked to these guys in 15 years. So don't ask me if they're still doing their thing. But I just pulled this off of the internet. The company that I talked to was called Buckman. And they're a company that does chemistry stuff, make chemicals. And the product that I used was called EBC1. And I'm going to read you the description of it. And Carl, I should send you this chemical name because it's the longest chemical name I have ever seen in my life. I'm not going to read it. But the description was, EBC1 from Buckman is a cost-efficient, highly effective coagulant that has a long history of use in industrial wastewater and surface water separation applications. Its low molecular weight, cationic nature, and superior stability make it an excellent choice for use as the primary coagulant in water clarifiers, wastewater, acronym, and as an emulsion breaker in oil in water industrial systems. I mean, that sounds right up our alley. So I call up these guys, 15 years ago. And I said, yes, this is Mr. Webb from Kinetic Precision, and we're thinking of using your chemicals. Can you send me a sample? And after a little schmoozing, they sent me, I think, 2 liters for testing. And I still have, as John saw, about a quarter liter left of this stuff. But this is...
We haven't finished our testing yet, but thanks for checking in. We'll let you know.
Yeah, we're still working on it. So I took the stuff, and I think I had a spec sheet. I couldn't find it today, but I had a spec sheet, used this much per gallon. Okay. It wasn't a ton. And mixed it up, came back the next day, and I had oil on top and water on the bottom. It was pretty neat. And Carl, it was, okay, I'm going to tell Carl what it is. It was 1,2-ethane diamine, N-prime tetramethyl polymer with 1' oxy-bis, open bracket, 2-chloroethane, close bracket, 60%.
Okay. The fact that it's chlorinated essentially raises a, how should one say? The problem with anything chlorinated is that we chemists can find it at the parts per billion level.
Yeah, it does say chloro in there. Yeah.
Yeah. So I would be reluctant. I mean, they may have, EPA approval to use this stuff in seawater to, to collect oil, but I would not want to put anything into the drain that is chlorinated.
Well, here's what they said. I pulled this off the inner tubes. This product is acceptable for treating boilers, steam lines, and or cooling systems where neither treated water nor steam produced may contact edible products in and around food processing areas. This product is acceptable for use in sewage and or drain lines in and around food processing areas. So that basically says, yeah, it could end up down the drain, but don't be a dick, basically. Anyway, long story short, that was my solution. It cracked it. It worked. I responsibly took care of the components, and that was a long time ago. So John and I have a phone call, have a discussion, and he ends up talking to an expert. Pick it up.
Yeah, so I had a call with a person who is a senior chemist at Qualichem, short answer. So I felt good that I'm talking to somebody who's, very much lives and breathes this professionally. And she was quite helpful. What she explained was that, speaking very much to what Carl just said, that you can't just give a carte blanche generic one type of salt or one type of chemical can help crack anything. She was saying that 250 or 251 in particular, and I'm going to use my notes written down on a quick phone call the day before Christmas, so cut me some slack here, but 251 doesn't handle hardness well, so you can actually just use Epsom salt to crack it, if you will. I asked her how much you would need to use, and she just said, I don't know. She wasn't being evasive. She just didn't know.
Yeah.
She implied that there might be some value to doing so if you're then going to have the water tested by a company. I don't know if it would be a safety clean or another type of certification type company that can basically say, again, my words, so long as you continue to do it this exact way, you will end up with water that is this condition. You may need to still have it tested each time, but that could be dealt with in one of many ways, which could include pouring it down the drain, again, if it met certain criteria. I've also heard from a Business of Machining podcast who wrote in that said they have a filter system. So basically they crack it and then they filter the water to get it to a point where it's okay to be poured down the drain. But for the most part, for most of us listening, this isn't a practical solution. What I was really happy to hear was I had asked this chemist, I said, hey, you had tested some of our water and some of our coolant for us recently. I'd like to send you more. They had done it for me for free. And to be honest, I don't always know if somebody's doing that for me for free because of who I am. Please note the air quotes here. And I just said, I'm happy to pay for it. What does that cost? She's like, no. Any Qualichem customer can send in any sample at any point in time and we will test your water or your coolant for you. And I said, really? She goes, oh no, we have customers that send in 15 samples a week, every week. And I go, oh, okay. So you're running hundreds of lab tests a week for customers. You don't care if I send in one a quarter. She's like, we could not, but we're happy to do it. It's what we do. So anybody out there, a mom and pop shop, a garage shop, a home shop, have your water tested. Talk to your Qualichem rep. And or if you don't know how to get in touch with them, I'm happy to put you in touch with somebody who can. But get your water tested, because I don't care what you do. It's always fun to at least be armed with the information about what does your tap water or well water look like? What does your sump currently look like? That to me was a really cool thing to know. Hey, all I got to do is buy a couple of clean plastic canisters and pay $10 to send it to their lab, and I think it's Virginia or Maryland.
It's Virginia.
And then the last thing I learned that was really educational was we were debating moving from a homegrown RO system to a commercial system. The problem with the homegrown system that we have is we create RO water, which we then have to store it, because RO effectively always drip feeds out. So it's not able to be created on demand when you need to fill up a sump, et cetera. And when you store water over time, there's always the risk that it goes bad or you have biological growth, et cetera, et cetera. And so I thought, we really need to look at a commercial system with DI tanks or something of the sorts. And she said, she actually urged caution because she has seen a lot of facilities that think, I'll just pay a water company to handle this for me. And again, my words, parlaying what she said, there may not be the examples everywhere, but a lot of these commercial systems, they're just checking a box. They're just going to swap your tanks out. They don't care about the system in the way that an owner might care. She's like, you're better off doing some maintenance on your own RO system because you care, John. You have those, like Spencer was mentioning, $20 on Amazon. You can buy hardness testers and resistance testers to measure stuff, to check stuff, to clean stuff. She's like, keep doing what you're doing. The aquarium RO stuff is totally fine for the volume you need. You need to be careful about storing water over time for bacteria growth. It can also really easily grow in PEX lines if you're using PEX lines like we do to distribute water throughout the shop. But it was nice to hear, I think some of you may have heard this Grims and I joke and give each other a hard time about when are we DIYing intelligently and when are we doing it ourselves to our own detriment. And it was nice to hear her say, no, you're on the right track. Keep doing it that way. But just know you may have to take care of a few things here and there.
That's fantastic. That was a good tone from a company.
Excellent,
right? From a company that we've been dealing with for many years. I've been very happy with the product, and the local representation was also very happy. Made me very happy. Let's see. Tim Beatty says an interesting thing. He says UV lighting is your best friend. I suppose you can UV kill bacteria. That might be an interesting thing to look at.
That is a way of killing bugs, but the problem is that the bugs can grow if you're using a deionizer. They can grow on the deionizer, and that's part of the reason that typically a deionizing system will have RO in front of it to get the bugs out. So you'll typically have an RO filter followed by what's called a mixed bed deionizer, which means that it will do both anions or positive ions and negative ions, and then it will have two polishing filters, one for positive and one for negative. And
look, I'm going to interrupt you, Carl. This is my problem. It gets so complicated so quickly. Similarly with the ultraviolet or UV or whatever, the problem is that, we could kill it as it drips out of the RO, but I still am storing 200 gallons. Ultraviolet's not going to solve a 200 gallons tank, so I could be cycling it through. It just all becomes messy quickly.
A polyethylene or polypropylene container will be perfectly fine to store the water that you need to store. Certainly you can use stainless, but that's going to be a lot more money.
I think if it became a problem, your nose would tell you. I think.
Well, if it's not obvious, we started to have a problem. That was what started a lot of this.
Oh, okay. Do you start smelling something?
I actually noticed a tiny amount, like a little green spot inside the IBC tote, and kind of looked like very faint moss. And so that's when we had our first batch tested. And then we started this whole discussion of what do you do? Do we really have a problem? Are we nipping this in the bud, et cetera, et cetera? And we don't have any sunlight in our shop, for better or worse. So it wasn't the case where we were having any exposure to sunlight in a clear container will absolutely promote growth. That wasn't our problem, but I don't know, Carl, if you know what an IBC totes are generally made out of. I assume they're a poly.
Propylene?
Would you say? Yeah.
I don't know what they're made of. My guess is they're probably either polyethylene or polypropylene, but I'm not certain.
So
Those are two things that are relatively inexpensive and relatively inert.
Yeah.
I have an idea for your situation, John, and we haven't talked about this, but of course this is going to cost you floor space, which sucks. Have a second tote.
I got plenty of credits.
Listen, I could send you some. You can have two totes.
I just got rid of 2 lathes. I am swimming.
Two what? I'm sorry. What did you say? Two.
You heard me.
Okay.
Don't make me say it twice.
I won't make you say it again. If you had 2 totes, you could have one in service and one being sterilized, basically, and then swap. When you empty the second tote, you switch to the other tote, and the other one gets cleaned.
Yeah, the practical answer from the quality chemist was more of like, look, use it for a year and a half, and then you need to empty it, power wash it out. You could power wash it with Purple Power, or you could use, they sell Eco Clean that has a very mild biocide in it. But look, the reality is it's going to take a little bit of work every year and a half. Not a big deal. That's for sure the path of least resistance.
So annual cleaning, annual maintenance.
Yeah.
All right, that works.
Yeah.
So if I could start to put the ribbons on this, if you're running a business, go ahead, Carl.
I would just like to touch on one point that was raised before about the order and the way that you mix the concentrate with the water. And the simple answer is do whatever the manufacturer tells you. Because they may tell you it doesn't matter, just mix it however you want, or they may tell you, do it this way.
Right.
And you may need a drill mixer or something like that in order to, get the whole thing mixed up.
So that's exactly what I have sitting next to one of my coolant tanks is a drill mixer and a 5-gallon bucket. And when my local rep came, we got to talking, and he says, "How do you mix up the Qualichem?" I tell him, I said, "Well, I have a 5-gallon bucket. I mix up 5 gallons worth. I use my drill mixer, mix it up, and then dump it in." And Mr. Tim Beatty says, "I only remember add acid to water." So the other thing was OIL, oil in last. That was the make sure you add the coolant to the water and you mix it. Anyway, so I was doing that, and the guy looked at me and he says, "You don't have to do that." I'm like, "Sorry?" He says, "With the Qualichem, just dump it in. You want to dump in more coolant? Dump in more coolant. You want to dump in more water? Dump in more water." And I'm like,
with 250 and 251, yes.
With 250
it's very tolerant.
And 251. Okay, yes. Extreme cut 250C. That's what I'm using. So that's what I've been doing now. And it's been just like a non-issue. So Carl was the smartest of the three of us.
May I insert a little bit of trivia?
Yeah.
The notion about adding acid to water it's not a generalization. It refers specifically to diluting concentrated sulfuric acid. The sulfuric acid is more dense than the water, and if you pour water on top of it, there's a big exotherm, and it will boil and it will splatter. That's why you stir the sulfuric acid into the water, not the other way around. But it's only that particular issue. It is not a generalization.
I have a story for the after party. So if you guys are wondering about what we do in the after party, I'm going to tell this story, but not here. I have a story about that. So I don't know. Did we? I think we brought it in for a landing. I think you in the back? Yes.
Spencer, didn't you say at one point you had access to a town facility that was willing to take some fluids?
Yes. So my town facility is willing to take oil. And so, but not, I think I might have even addressed that a million years ago, but I said, well, I'm going to bring in oil from my machine shop that is, ready to go. And he goes, oh, no, only car oil. And I said, I, and I said,
Yeah.
oh, so if the oil is very dark and it smells like oil, then it's okay. Okay. I walked away. The guy I was talking to was not a PhD. So that's what I do. I don't bring a lot of, I don't have a lot to recycle, but I bring oil to the town, recycle it. Everybody's happy. And then I evaporate I have a big evaporation tray, for water, and I just dump it in the evaporation tray and it evaporates. So yes. Does that answer your question?
Yeah, I was just trying to bring it home. If you need to get rid of 10 gallons a year and you're never going to work with Safety Clean, is there a way that you could potentially find, whether it's maybe a friend of a friend who's got a business who would take it from you, or a town recycling center, just to avoid the whole, just close your eyes and pour it down the drain scenario?
Yeah, never do. First of all, let's put this out there. Never do that. Never dump coolant down the drain. Never dump coolant into the city drains. Never dump coolant into your septic system. If you don't think it was cheap to have it picked up, you will figure out that it was cheap to have it picked up after you have to replace your septic system. So do not do that. What do you need? You need an end game plan. And if you have no end game plan, maybe you shouldn't be using flood coolant. Maybe you should be using minimum, MQL and call it a day. But what I did is I cracked it. I cracked it with a chemical, which I got through social engineering. And it's really a neat chemical. I like it. A chemist told us that for certain coolants, you can crack it with a salt, in this case, Epsom salts. You still have to deal with the salty water. I guess if there's a message here, is there's no simple recipe, but you should have a method figured out before you commit to having 55 gallons of coolant running through your system. If you're a business,
ask your rep. Your rep could probably help you out if you're a small shop. Like, hey, I need to get rid of 5 gallons, and maybe help figure it out.
I think the reps are pretty amazing. The fact that they test your water as much as you want and test your coolant as much as you want, and they're very nice. That's a really good piece of advice.
That's a great vendor.
Talk to your rep, but do it consciously.
I have a friend who lives in Center Conway, New Hampshire, and there you take stuff to the dump, trash and so forth. And I think once or twice a year they have a hazmat day where you bring them hazmats.
Yes.
And you probably have that where you are, Spencer.
Yes, we do.
So,
and you know what? That's a really good question, because I don't think I ever asked if I could bring coolant. I'm going to ask.
Well, respectfully, here's what I would theoretically do if I were somebody else in that situation. If you really need to get rid of it, crack it, separate it to the water. You can let the water evaporate, and take that remaining amount, put it in a 5-gallon bucket, buy the lid, seal the lid on there, take it to your hazmat day, and just say, hey, this is like whatever, just leave it. Like, that's better than a lot of alternatives.
You know what? That's the whole hazmat day idea is an excellent idea, because we have it. I think we have it once every couple of months. There's a big hazmat day.
Oh, wow.
And you could the idea is bring anything. And they're pretty good about it. So that's a really good piece of advice. So, Carl, any final thoughts?
I think we've covered everything, or at least anything that I can contribute.
Okay. And if anybody needs to get a hold of Carl, just show up on our Discord server and we'll take your question and deliver it to him in handwritten form on parchment, and bring it to him personally.
I'm on Instagram. My handle is deflagreat, and you're welcome to message me.
DEFLAGRATE.
GREAT.
Defla, great. DEFLAGREAT. Deflagrate on Instagram. Thank you, Carl. Mr. John Saunders, thank you for being here and sharing the continuing journey of what the heck do I do with this coolant. And I did, and thanks for sharing some new information I didn't know, and talking about this excellent contact at our favorite coolant company, Qualichem. # not sponsored yet. Just kidding. We're not soliciting anything. And we're looking forward to following up. Maybe we follow up in a few months and see how we're doing. Is that a good idea?
Well, that'd be great, because I still, for fun, when it comes summer or spring, I actually still want to take 5 gallons or a gallon of coolant and try my evaporative idea as a science experiment, not because it's ever going to make sense for us, but I want to see, can you evaporatively reduce this down in a fun way? So I'll let you know what I learned. But
if you were looking for a bunch of nerds to share that information with, you have found them. Because that's exactly what we want. Is that your assistant there?
Mama, you say hi? Oh, he left.
He left. He's the smartest of all of us. All right. Mr. John Saunders, Mr. Carl Tauber, thank you so much for being here. And with that, we're going to wrap this thing and remind everybody to get flat, stay flat, and we'll see you guys next week.